This is chapter 26, example 6. So what we have here is a circuit that counts the number of times a equals b, then a is less than b, then a is greater than b, and it counts those on an active clock edge. So the issue is it counts up to 50. When it hits 50, then it switches to the next node. So it counts how many times a equals b. When it sees 50 of those, it switches to a less than b, sees 50, then switches to a greater than b. So the inputs here are 10-bit, unsigned. See if there's anything interesting in this. Okay, the circuit has two sets of outputs. One is just the count, and the other one is a single bit that indicates whether it's looking for a equals b, a less than b, or a greater than b. So that's enough to start with. The count counts up to 50. 50 needs 6 bits, so there's 6 bits for the count. It has three outputs here. And it has 2 inputs, A and B. Once again, we're going to look at this and break it down. That thing's super new in this one, but not a trivial circuit. And so we got to look for things that we're used to seeing here. It counts to 50. It counts the number of times a equals b, for example. That is going to be an event counter, so we know we're going to need a counter in this. So let's go ahead and draw a counter. So there's our counter. I'm not actually sure what to do with the clear yet. I know we need to clear the circuit, so I know I need to clear. I'm not exactly sure how it works. And that's okay, I'll figure it out later as I put more stuff down. So the next thing this circuit obviously has is a comparator. It's making comparisons. So there's your A. Notice things are not hooked up yet. I'm not quite sure how it works, but I know I'm going to need to control this with a state machine. So I'm just going to put these in here. So these are control inputs, so they're going to be outputs of the state machine. These are status outputs of the comparison. I think these are going to be inputs to the state machine. So once again, I'm not really sure exactly how this is going to work, the details, but I will figure it out when I get there. The circuit is kind of operating open loop, so it doesn't really matter where we start. A lot of these circuits have a start button. This circuit doesn't. So at this point, we're ready to draw the state machine, and I feel like it has 3 states, one for each thing it's looking for. So let's go ahead and draw that. So we can use symbols in the names because it's going to keep us from clashing with these symbols right here. I am going to, well, heck, I suddenly realize I'm going to need another part of this circuit. And so I need another comparator in this circuit. So it needs to compare the value to 50. So it needs to compare the count value to 50. And so once again, I didn't see that before, but I saw it now. Design isn't linear, it's circular. I'm going to go back and fix that. This is, we'll call this one EQ50, and it's going to be comparing this 6-bit output to 0x50, which is 16 times 3 plus 2, 32. So this is my a 50 that it's comparing to, and when those are equal, it kicks out this signal right here. I should have caught that before, but I didn't. No big deal. I fixed it. I found it now. It's going to stay in this state so long as EQ50 not. Once I get EQ50, once it becomes 50, I'm going to move to the next state, EQ50. And so what I'm looking for in this thing is I have to assign these 2 inputs in both states. Now the way, not sure how to do this yet, but I think what I need to say is up equals EQ. I still have to figure out how to do the clear. I'm not there yet, I don't have to worry about it, but I need to handle these 3 signals in each of the states. And so I'm going to go ahead and put those in. It's going to take a minute. in this state, I'm in the A equals B state, so I want to turn that LED on and turn the other two off. And so I can do that in these other two states also, so we can call that kind of done. So we've got the outputs handled. What we need to do is handle the clear input. So what we're going to do here, I think this is going to be a Mealy machine. So we're going to write this as we've been doing many times, and we're going to put it like that. And I'm going to think, I'm going to call that working. We're going to come back and look at that to make sure that's working. So these other states are going to be very similar. Yes, very similar. Unfortunately, I didn't leave enough room for them. It's not well planned as far as space goes, but looks good. Now the one thing to notice, these three states here, they're very symmetrical. They're almost exactly the same, and we can continue with that sameness here is by say up equals LT and up equals GT. At that point, the one thing I'm worried about in this circuit is when exactly it rolls over. So what's going to happen is when this is equal to 50, this clear is going to turn on, because we have it here equal 50, the clear turns on. Okay, so the issue is before we have these asynchronous, but if we do that now, it will hit 50 and immediately clear. So essentially, if it's asynchronous, it clears immediately. I don't want that. What I want is to put a note here and say clear equals synchronous. Because it's synchronous, it waits till the next clock edge. That gives me that 50 count for the entire clock cycle. It doesn't clear immediately. I can see 50 on the output. The other thing I need to say in the circuit is up. Typical event counter stuff. Call this problem done. I have to know how this problem is controlled. So obviously it has circuit control because it has a state machine in it. Only thing we have in here is circuit control. And so we're going to call this problem done. I'm going to take one final look to make sure I've got everything done, and I don't have everything done. So this is EQ50. Needs to be an input on the state machine. Blah, blah, blah. Okay, now I'm going to call it done.